So in today's lesson, I'm going to be talking to you about converting units. So in our more math-based science courses like physics and chemistry, and certainly those units in our grade 9 and 10 science, there may be cases where when you're solving a problem, you might want to convert from one unit to another. It's not unheard of that the formula that you might be using might require you to use a particular unit of measurement, for instance centimeters, when you might be given inches, and so the formula won't really work properly if you don't have the correct unit to input into the formula. So the process that we use to make that happen is called dimensional analysis. And dimensional analysis is basically just that. It's a process by which we perform unit conversions. So I want to do more than just simply show you how this works. I want you to understand why it works. So before we do that, I'm going to present to you a couple of really important ideas. Okay, so what we're going to be doing in the process of dimensional analysis is we're going to be multiplying by a factor. So one of the factors, well, each factor, that is going to be in the form of a fraction. And that fraction is going to be a factor that relates one unit to the other. Okay, for example, I know that 1 kilometer is equal to 1,000 meters, right? So if I multiply another number by that factor, I know that I'm not like, so for instance, let's say I have 5 meters and I want to convert that into kilometers instead. I know that by multiplying it by this factor, I'm not changing the size of the measurement, I'm just changing the unit, because really a kilometer is equal to 1,000 meters. Those two values are equivalent, and so I'm not really changing the measurement, I'm just changing the unit of the measurement. So that's the first part. Now, the second part that I want to talk about is canceling units. So, I'm going to use the same example as I've just used, right? I've got 5 meters, and I'm going to multiply that by 1 kilometer divided by 1,000 meters. And what I'm going to try to explain to you here is why I can say this. I can cancel this top meter right here with this bottom meter right here, right? So I have a meter in the numerator, that's this guy, and I have a meter in the denominator, and those units will cancel out, leaving me with my desired unit. But my question to you right now is, well, why does a meter on top cancel with a meter on the bottom? Well, let's work out this calculation for me to show you why that works, in case the math is confounding for you. So I know that this whole 5 meters right here is a whole number, and that I can write any whole number as a fraction over 1. And so now what I'm going to do next is I'm going to go ahead and I'm going to multiply across the top, numerator with numerator, and denominator with denominator, because that is how we multiply fractions. And that's what I have essentially, right? And so what I get as a result is my 5 meters times 1 kilometer, right, which will give me 5 meters times 1 kilometer divided by, well, 1 times 1,000, so 1,000 meters. And I know, just like if I had variables in the numerator and the denominator, if I had the same variable, those variables would be able to divide out, because a meter divided by another meter, a meter divided by meter, just like anything divided by itself, will give me 1. So those meters will cancel out. So that is the basis for why it is that we're going to be able to do what we're doing when we're utilizing dimensional analysis. So students will often say, well, I know an easier way than the method that you're showing me to convert units. And I will say to you, that's true. And fundamentally, I am concerned with you understanding how to get the right answer and understanding why your answer makes sense. That is, for me, number one priority. But I'm going to give you an example just to give you pause for thought to think about how maybe you don't have all the information right now. So, and I'd like you to just trust me and trust this process. So I'm going to start with a simple example. So in grade, I don't know, maybe grade 6, grade 7, they would give you a question like 2x is equal to 8, right? And, you know, in grade 7 or grade 6, whenever they teach this, the first method they will usually teach you is guess and check. And so you can very easily see from a question like this, just by using mental math, right, that the value of x in this case has to be 4, because I know that a number times 2 has to give me 8, right? So guess and check. But you get to the point in math where the guess and check strategy isn't the most efficient. In this case, was it the most efficient guess and check? Absolutely. However, you get to the point in, like, I don't know, grade 10, we saw questions like, 2.5x x plus 7.9 equals, and I'm just totally making this up, 5.3x. And I would say to you, like, could you guess and check the answer to find your x value? Sure you could. But is it the most efficient? Not really, right? So what we want to do is we want to find methods that will allow us to make calculations and convert units efficiently. And so the process that I'm about to teach you, we're going to start with some simple examples that, yes, maybe we could guess and check them more efficiently than using the process, but they're meant I'm meaning to start out simply to show you the method so that you understand the method before we go on to harder problems where the process of dimensional analysis is probably more efficient than guess and check. So I'm just going to ask you to trust me. So I thought, just to give you an idea, we're not doing this question, by the way. This might be a grade 11 question, grade 12 dimensional analysis question. I think actually grade 10s could manage it, but that's not really what I'm meaning to do. But here's an example of a case where you see, if you were to stop and read this question, I'm not going to do that. You can see in this question how there are, multiple units that have to be converted from one to the other. Two friends decide to go to Mexico City. They want to know the cost per person, and they give you a bunch of data. And as it turns out, you need to use multiple units to convert, which results in a lengthy process. And if you kind of do it, kind of guess and check, yes, you can do it, but it might not be the most efficient. Okay, so without further ado, let's get on to our process. Okay, so again, this is a simple example that I can probably do in my head. I don't need to use dimensional analysis to do it. But having said that, the point of this is to explain to you how the method works and why it works. So this is the basic setup. Okay, I am looking to convert 2.5 kilometers into meters. Okay, so you start off with the unit that you're given. So in this case, I'm given 2.5 kilometers, right? And what you want to do is you want to set up your unit conversion factor. That's that fraction that I talked about. And so the unit that I want is meters, which means that I need to get rid of kilometers. Okay, so in terms of math, I know that I need to put my kilometers on the opposite side of the fraction compared to where they exist in the original value so that they cancel out. And I'll show you that in a minute. And I want the unit that I want eventually to end up with to be on the other side of that. Okay, so now I've done my setup where I can see that, once I do the math, this kilometer will divide out, those kilometers will divide out and cancel. And what I'll be left with is this lovely unit of meters. Okay, so the next thing I need to do is I need to input what the relationship is between these two units, right? So I need to think, okay, well, what is the relationship between a meter and a kilometer? Oh, well, I know that 1 meter, nope, it does not. Let me redo that. I know that 1 kilometer is equal to 1,000 meters. So that's what I need to put in. So the 1 kilometer is equal to 1,000 meters, right? And so now all I need to do is simply go through the motion of multiplying across. Now again, you know, would moving the decimal place and just using your brain work faster for this? Probably, definitely, but I'm just trying to illustrate the method here. So I would go 2.5 times 1,000, dividing by 1 is not going to change my value, so that's just going to give me 2,500 meters. And I'm done, and I can see again my kilometers canceled out. The unit that remains is meters. That is the unit that I'm looking for. All right, so I want you to pause the video and give this one a try on your own to see if you can get, if you're on the right track with understanding this process. I'm going to come back with the solution in just a minute. Again, what is important here is not that you get the right answer, but that you understand the process of dimensional analysis using these factors. Okay, I'm going to go ahead and I'm going to give this a try. So I've set up with the unit that I have been given, and I know that I want to eventually convert that into kilometers. And so what I'm going to do is I know that I need to be able to cancel out these meters, and so my meters need to go in the denominator. And I'm going to put in the numerator the unit that I'm looking for. And what this does is it allows me to cancel out those meters, because I've got a meter on top here, which will be divided by this meter on the bottom. And that will leave me with my unit that I'm interested in. And I know that the relationship between a kilometer and a meter is that for every 1 kilometer, I have 1,000 meters. And so really, I'm going to say, you know, all right, 1539 meters times 1 and divided by 1,000, because 1,000 is in the denominator. And so that will give me 1.539 kilometers. Hopefully you did that okay, and if you didn't, you recognize your mistake and you'll be okay to reach out to me. So I just wanted to show you that this process also works when you have units that you're familiar with that aren't kilometers and meters. So, you know, here's a quick example. I'm going to go through it quickly. Hopefully you'll be able to follow along. If not, pop in and ask me some questions. So, 3.25 hours. Now, just again, this I could do by not using the method, of course, but I want to illustrate the method. So I want to get rid of hours. Where do the hours need to go? Oh, they need to go on the bottom. What unit am I looking for? I'm looking for minutes, so my minutes need to go on top. So what is the relationship between minutes and hours? Well, I know for every 1 hour, there are 60 minutes. So I'm just going to put that in, right? 60 minutes is equal to 1 hour. And so that I can easily see that my hours cancel. I'm left with units of minutes. And then when I work the math out on this, I will get my answer, and my answer will be in minutes. Okay, next question. So here's a question where, you know, the units don't relate to each other easily. And there are a number of different ways that you can work through if you really understand the relationship with these units to convert. I'm going to show you how a dimensional analysis approach to doing this. Okay, and then we'll give you one to try. So as always, I'm going to say, all right, well, 875 millimeters. I want to convert that into kilometers. So at the end of the line here, I want to get kilometers. So that means I need to get rid of my millimeters. But let's just say that I don't know the direct relationship between millimeters and kilometers. But I do happen to know that, you know, there are 1,000 millimeters in 1 meter. I can convert that into meters, right? And so in 1 meter, 1,000 millimeters. And if I were to stop right there, then all I would have done, if I worked this out, all of this out, would be to simply convert it to meters. But I don't want meters, so I need to keep going. And so what I'm going to do is I'm going to say, all right, well, I don't want meters. I need to get rid of these meters. So I'm going to put them down here. And that will cancel out these meters for me. But what unit do I want to replace those meters with? Well, the question is asking me for kilometers. So that's what I'm going to put in here. I'm going to put, well, kilometers. And as we saw in the earlier examples, I know that 1 kilometer is equal to 1,000 meters. And so, you know, that is what's going to allow me to convert. It's just the same process as before, but just 2 steps instead of 1. If you know the direct relationship between millimeters and kilometers, you can certainly use that. This is a kind of a let's break it down into smaller pieces approach so that it may seem more manageable to you. So let me work that out. So I would say the raw value that I'm getting for this is 0. Oopsies, I don't know what happened there. Let me try that again. And third time's a charm. 0.000875 kilometers. But you know, this is kind of ugly and cumbersome, prone to error with those zeros. I'm going to just convert that to scientific notation. 8.75 times 10 to the power of, it's less than 1, so negative. I moved my decimal place 1, 2, 3, 4 spots, so -4 kilometers. And there we have it. I'm going to get you to try the next question on your own. Here it is. Give that a whirl, and then I'll come back with the solution. Okay, so I've gone ahead and what I've done is I've done the setup here. So I chose to use my factors. I chose to go from kilometers to meters and then meters to centimeters instead of doing it directly. But if you didn't, your answer should be the same. And so all is good here. So I started by saying, oh, well, I need to get rid of kilometers. So my kilometers are going to go on the bottom. Boom, boom. And then I need to, so I set up the relationship between kilometers and meters. Then I said, well, I don't want meters. I want to get rid of my meters, so I need to put another meter on the denominator of the second factor. Boom, boom, gone. And so that allows me to have centimeters remaining. So then all I need to do here is to simply go ahead and multiply across, and that will give me my final answer. Hopefully you did okay with that. But if you struggled, make sure to reach out and I can help clarify for you as best I can. So now what you should be able to do, I'm just going to switch over. This is the worksheet that we have for class. So now at this point, you should be able to do question number 1 for sure. So I would say give yourself a bit of time to work through this process. Again, it's the process that matters, not the answer. It's the process I want you to figure out because, you know, in grade 11 and 12, we're going to have much more complicated factors to work with. And I want you to be able to handle any of these factors. Okay, so when you've done that, come back and we will meet up to do the second half of this process.